Project Candyland. I'm Derek.
I'm Gautam.
I'm Vishwas. I'm James.
We'll be discussing drone interactions. Okay. So the agenda that we'll be going through is as follows. We'll kind of go over the project. We'll talk about our methods. We'll talk about our design, our process. We'll talk about the pre-summary and post-summary that we went through, the results and our analysis, and then future work, of course, after conclusion. So the overview, essentially that's far more large words than really need to be stated, but it's for conciseness. So essentially what we're looking to do was test human beings' interaction with a given map and game tiles as you're moving these tiles to a given objective, which was what, which was a specific space on a game board. The reasons we were looking for this was to looking to experiment with this was to reduce cost in a user interface as well as create a standardized platform in the future. So our interface was really simple, as you will see, but it's a starting point. So right now that's kind of what a pilot's console looks like, and we're looking to simplify that. Right now we have a two-dimensional plane, and we'll talk a little bit more about what the pilots thought about that, but that's what they're used to. And we're also looking to compare how a non-pilot versus a pilot will be able to interact with this system, and whether or not one or the other would be better at it. So the existing methods right now for this kind of planning that we were working through was a map planner. And you'll see that ours is very similar to this, but this is far more advanced, and so we literally made it far more lightweight. As for our design, we used a processor that was very, very graphics intensive in order to process what was coming through the Leap and the Oculus, and then render that for the individual in real time. We used an Oculus Rift, a Leap motion sensor, and then Unity was our platform.
So this was the overall layout of our experiment. As Derek mentioned, the overall aim was to test the human interaction in a virtual setting. And so we started with our pre-surveys. In our pre-survey, we asked some questions about their prior experience with the Oculus, their prior experience with the Leap motion, or how many games they have played, or if they had any experience in a virtual setting. Next were the instructions. Instructions were how to perform the experiment, and we had a total of 15 participants. Out of that, there were 4 trained professional pilots and 11 regular people, non-pilots. And the second step was showing them a video of a visual of the instructions. And the third step was the calibration of the Oculus Rift and the Leap motion. In this calibration step, the participants were made to wear the Oculus Rift, and they were shown void environment, and they could see the rendering of their arms in that environment. And after this, they were shown the introductory environment. In this, the goal of this step was to make them comfortable, using the Oculus Rift. In this, they were shown a table with different objects on the table. The next step was the actual test environment. This was the test environment that we created using the Unity game engine. In this, the overall environment was laid out with a 2D GUI, and on that we had 20 beacons. And the goal of the experiment was that each participant had to collect all the 20 beacons in a total of 15 minutes. And in this experiment, we recorded the number of attempts that the participants took to reach to collect each beacon, and also the time taken to collect those beacons. After the experiment was completed, the participants would take off their virtual headsets, and then there was a post-survey. In the post-survey, we asked questions like how comfortable were they performing the experiments, and if they had any mental or physical strain, and if they had any recommendations for us. So on the top right, this is the introductory environment I was talking about, the tabletop with some objects on it. On the bottom right is the actual environment. This is a short video of from one of the participants. So this is the actual environment, and we have overlaid the actual environment with a 2D GUI, and in this, the green parts are the beacons, and there are 2 quads on the scene. These switches are to like switch on the quads. And once a beacon is visited, it is marked as red, and like as I mentioned, there were a total of 20 beacons, and the total time was 15 minutes.
Right. We had 2 different runs. The first run was the pilot testing. Just we wanted to know if there are anything that we need to fix. So we got 9 participants for that event, which was a part of it. In that we found a couple of bugs, especially when there was drag and drop of the drones. There was like discontinuity between the routes, and all the 20 waypoints were on the system. So we decided we got to come up with a system where the waypoints are just 2, and then when the drones cover them, that's when you come up with a new waypoint, then you traverse. So those were the things that we identified in the first run, and in the second run we fixed them all. And in the second run, again, there were 2 sections. In one of the sections, we conducted the experiment with the 4 military trained pilots, out of which 2 were 2 specialized in the UAV. And then there were 11 non-pilots in the last part of the experiment. We couldn't find many female participants, and that's one of the things that we lack in this. But again,
emails now. Spam emails.
So yeah, we couldn't draw any conclusion based on the gender. Yeah, the pilots and non-pilots, we've got a certain amount of data that we can draw conclusion on. Measurement of success was to see if the participant completed all traversing to all 20 waypoints, and the number of attempts the participant takes in drag and drop in on each waypoint. And why we wanted this was because at the start it might be difficult for you to get adjusted to the interface. As and when you go on, there was a trend. There is a trend that shows they were finding it far more smooth to interact with the interface. Also, some people were frustrated after 15 waypoints, and they were like, "Oh, we just want to finish it off," sort of thing. So those were the things that we observed. We had 2 pre-survey questions, and these questions, the agenda of these questions were to see if they had any prior experience and if that would affect the way they perform, or if they had experience in using Oculus Rift, and did that matter. Also, if they had any general perspective of handling a UAV using a virtual reality, how did they think about it at the start. And in there you can see the 4 and 5, they say like 0 and 0, they said it could be tough, or they didn't have any clue about it. But in the post-survey, you can see the 4, everyone felt if this is the interface that's given, then we find it sort of okay or easy to handle UAV. So that's the contrast between the pre and post-survey. The red are the pilots. They had experience. You can see that shows the experience of the pilots. They never had any experience in either using Leap or Oculus Rift. And the 8th one is, the 8th question was if they played any video games. We wanted to see if people play video games. Usually in most of the surveys we see if people who play video games have good decision making and judgmental thing. In the post survey we can see the mental and physical strain was less, not too significantly high, but asked about how did they think about the interface, everyone said yes, and it was easy for them. The scale is again like the scale from 0 to 4, 4 being the highest. The red shows the pilot data, and the pilots felt more easier to handle, and even they performed better compared to the not pilots.
So this is just a takeaway from the distribution of who was a pilot, and this is their experience with handling a real aircraft. Keep note that the pilot is categorized as a professional trained military pilot versus one of our participants is a pilot, but he just has his pilot's license. This is the same thing with UAV experience. We had 2 guys who it is their job to fly the military UAVs like the Ravens and the Global Hawk. And the rest are like hobby quadcopters over there. So what we wanted to see kind of happen, which was that there was really no distinction between a pilot using the interface or a non-pilot using the interface. So using that, we were kind of excited to be able to conclude that maybe we have built an interface that actually anybody can pick up and use and be able to work with. So this is the number of attempts based on the experience of UAVs. And so now we're going to see that the background of each participant really had no effect on the outcome. So because this is the mean number of attempts per, average mean number of attempts per participant in trying to move the vehicle to a specific location. Again, this is it for the aircraft experience, and we see that there's no trend, and both ends is just completely, there's no trend. That's what we wanted to see.
Someone with 0 experience had to do over 8 attempts. They must have been pretty frustrated.
So there's a couple reasons. I'll kind of talk about some of that. Some of it is just our development. We had some technical problems, but we'll talk about that. And so this is the video game comparison. So once again, playing video games didn't have any effect. So the most important graph was this, which was as the person had more time in the environment, they got much better. And then we actually see a point where they actually get worse, mainly because we think it's just they figured out, like, we know how to do it and now we're over it. So that's okay. I mean, the one guy was really struggling. That was because of one of the locations and he just couldn't get it. So I think there was like 11 tries. He wound up telling us that he wanted to go again, and his other run was actually the best run ever, but we took it out since he did it twice. So we tried running some statistics on it, but because we have such a small population, or a small sample size of pilots and non-pilots, so this is the QQ plot, and it's very skewed right. Ideally, we would like it to be kind of normalized, so when we did try to run like a Wilcox test, it actually failed on us, and you can't really run a t-test on skewed small data sample size, so that's unfortunate, but at least, this is really what we wanted to see, was a decrease in trend, and specifically the performance was pretty average across groups, so we kind of took that away as a success there. So here's some quotes. We're just like, this is really, really cool. One of the UAV pilots said, when you build the next version, contact me because I want to try it again. And one of the interesting ones, this was Derek's dad, which was all about the 3rd dimension, and he wanted, more pilot information that we may or may not agree with, but he wanted like all these other factors that he's used to flying with, and we really wanted to remove those factors and make it even easier for anybody to pilot the vehicle. So, in conclusion, people were able to perform the task, but we had some technical difficulties with, there was only one type of like good movement that was able to move the vehicle. So if you tried to push it or didn't fully grasp it, it would kind of drop out, and in some cases actually fly away. And that was a bug that we knew of that we didn't really know how to fix within the allotted times. So we just basically would try and restart them, and that's why we got rid of the timestamps as well. And so we just wanted to make sure that each person had 20 attempts, or 20 beacon experiences, and kind of grade over that. So We also wanted to have more participants. Unfortunately, the experiment takes a little while, and we can only do one at a time, and we kind of had to have time slots. So we had a lot of people signed up, not a lot of people would show up. So that's just kind of unfortunate. And so for our future work, we considered getting rid of actually the grab and drop placement and more of a touching screen placement. That was actually suggested by most of the participants because this was just kind of difficult. Again, more people, we wanted to throw in more vehicles, as well as be able to conclude that you're in the environment. It was kind of hard with the 2D screen in here to understand that you were in the environment with the drones flying around, which you could do. But that was due to the fact that we took out one of the components, which was the user's ability to fly around in the environment and actually search for the beacons themselves. And that was kind of an initial prompt in the experiment. We did it for the first person, and as soon as they did it, they got super confused, and we just said, nope, we're taking that one completely out. So I'd say at the very end though, based on this trend and on this, it seems like we might have figured out an interface that makes it pretty simple, and so we're pretty happy with those results.
Cool. All right, let's open the floor to questions. Yeah, that seems like pretty compelling results to me. I think, as you guys talked about, at least for my run, the bottleneck seemed to be the leap motion and the grasping. It seemed like that failed a lot for me. So that'd be something to look into. I think, yeah, by design this was a bit of a simple interface, but was the idea to eventually move to like a cockpit style? Because then you could really...
Yeah, we wanted to be able to manipulate, we'll just leave it here. So manipulate the things that you have in your environment, and actually we had more stuff, but we took it out because it's just complicated.
Mm-hmm.
You know, we really then felt that what we wanted to look at was if this type of interaction that everyone's used to, like if I wanted to move something from A to B, I physically pick it up and move it. And that's what we wanted to look at. But honestly, most people would get in, we actually started the video because people would get in the environment and just start trying to push things.
Yeah.
And so we were like, try and grab it and then move it around.
Could you go back to the motivation slide from some of the first slides? So yeah, so if it's training, if it's pilot training. Yeah, see that seems like really appropriate to me. So is that eventually what you'd want to do, or are you actually trying to do that?
Yeah, so we'd like to continue doing this. The next step is actually, I'm going to hook it up to a real simulator versus just like some floating, they're literally floating cubes with drone renders. So hooking it up and actually ground truthing it, because we know this environment, the reason we needed a big computer is actually like half of Colorado that you're sitting inside. And if we turned it on the ability, you can actually fly around and navigate in the world with your vehicles, which is what we wanted to have to kind of bring back some, environment recognition and kind of, make it easier for them to understand the environment that they're working in.
So when these guys are flying drones, they're like switching in between like, they're looking at a satellite view, and then they're also like going to the first-person view of the drones, and.
So they sit in and actually a pilot's like in a chair similar to wherever it is. Similar to this, except a lot of those gauges are moved up, and then you've got a computer screen that shows what the camera's looking at.
Okay.
You still have the joysticks and everything. So it's an airplane, but they only do takeoff and land. Other than that, it's a keyboard and mouse. And then the center screen between two pilots or another chair is like a glorified Google Maps, and it actually is Google because the energy.
Cool. So you kind of move like a baby step to simulating that.
Yeah. So we'd like to, be able to integrate. So if the pilot wanted to fly somewhere, we load them into that world where they're actually piloting the vehicle, and then we can render them in different views.
Okay.
And they really like that idea. So that you could have, even though it's not the real world, it's close enough. And if we can render them as like even a third person over top of the aircraft, they'd be able to figure it out a lot better and know like where things are spatially.
Cool. Any other questions?
So how much of the big complicated interface would need to be added back in, like at some point in the future?
We want to try and remove a lot of that and leverage the increasing autonomous capabilities of like unmanned vehicles, because 90% of the time it's like a point and click and they just kind of watch the screen. That's really what their job is watch what the payload is looking at and just track objects that they're looking for. And so having all this may not necessarily be very necessary, or at least have the ability to remove it and only bring it back when they wanted it.
Yeah, I mean, it's always necessary to have those gauges available to you. It just may not be necessary to actually be looking at them at any given moment in time. It's just a distraction, honestly. You're trained to cycle around those periodically, and if you aren't trained to do that, that's overload. That's just way overload.
One of the tricky things I imagine is it's really hard to beat the fidelity of like just a mouse and keyboard. So that's like that's like the gold standard. So.
Yeah, well, they have it's a touch screen when they do the waypoints.
Oh, okay. So
they
okay.
moved up.
Okay.
Yeah.
Is it the same for what you just described? The same for commercial pilots? Because I think they're more trained to actually look at the telemetry that they're getting, because they cannot trust the outside at all.
It depends. I'm not quite sure what you mean by outside. Can you be a little bit more specific?
Like if they look outside flying by looking outside rather than a fighter plane, where it might make sense. They have to trust what the telemetry of the altimetry, their bearing, it's telling them a lot more than what their eyes can tell them by looking outside, because they can get it very easily disoriented in what bearing that the plane is.
It depends on the conditions, and it's basically the case if you have any clouds in the sky, then you're always checking your gauges, always. Especially at night too, you can't trust anything at night.
Yeah,
It's all gauges, and that was one of the things that my dad was making sure that we incorporated in this, that we could then also simulate nighttime environments, cloud environments, stuff like that, because the gauges are absolutely critical there. As for autonomy, for the drones and things like that, we want to have them be able to do as much as the pilot can do, and then when the pilot wants to take control, it should be very fluid, where it's like almost like when you press the brake, right, then your cruise control goes off, right? But if I were to just let go of the wheel and my car started deviating, well, the thing should start taking over. It's kind of like if I just let go of it, it should rapidly figure out when I'm deciding not to be in control anymore.
Cool. So you guys looking to commercialize or?
Yeah.
Not yet. What is that? Is that a
That's
dream?
long term.
That's long way.
I mean, it would be fun. We're going to be working with Ollie now, because he wants to use like a training system for his gesture droney thing that he's working on. So I know Derek and I think are doing an independent study next semester with him and incorporating what he's doing with what we've got so far.
Cool.
Which would be kind of fun.
All right. Good job. All right, that's it for today. Team GUI obsolescence.